Good morning, students. This is Anjali, Assistant Professor, Department of CSE, AIML, IARE, Hyderabad. Today's our topic name is Definition and Terminology on Flavors of Data. So, Flavors of Data is our first module. We will see just definition and terminology, which definitions we have to cover in this module. Previously, we have seen problem solving on this topic. So, we will see one by one. First, topic name is data. Students, you are very familiar with this name, data. Data means just we can say that facts, figures, informations which we can store in our used by a computer. Or we can say in other words, data does not carry any specific purpose. Actually, it doesn't have any purpose or it doesn't have any specific significance. So, data is measured in terms of bits and bytes, and which are basic units of the information in context of computer storage and the processing. You people are continuously listening about the data. But data means just we can say the information, but both terms are very different. We can say data is plural form and its singular form means it's a datum. Datum is a singular form. For example, we can say the data is information which are collected for the research paper. If you want to write paper, if you want research on any topic, so definitely for that you have to search, you have to analyze some data. Or we can say the data is an email. Now what is meant by the information? Actually, information is processed, organized and structured data. Data and information somewhat are similar, but both are different. Data means just that data will be unorganized format, unprocessed format or unstructured format. Your data will be in unstructured format, unorganized format or unprocessed format. But information is not like that. Your information will be in processed format, it will be in the organized format and it will be in the structured format also. So mainly it will provides the context for the data and enables decision making. If your data is in the processed form, organized form, then structured form, so it will be very easy for the users to take any decisions. For example, single customer sell a restaurant is data. This becomes information when the business is able to identify most popular or least popular dish. Single customer sell will be your data. But if there is any famous famous dish that is very popular dish and least popular dish, so that will be information. This is your information, but this is your data. Now we can see the difference between the data and the information. I already told that your data is unorganized format, unstructured format, unprocessed format. That means data means we can access the data from any source and just we can collect the data in one format. So that data we can say it is unorganized, unrefined, unstructured, unstructured, unprocessed also. So this is data. But what about the information? Information is totally opposite of the data. Information generally will be in processed format, in organized format, and the data will be in the meaningful context. The data will be meaningful. So we can say data is an individual unit. Data is individual unit that contains the raw material which do not carry any specific meaning. Whatever you have collected data, whatever you have accessed data from various sources, that data have not any meaning. But information, if you have collected anything, if you have collected information in the group of the data that will contain, that will carry a logical meaning. So data doesn't depend on any information. But keep in mind, information depends on data. So raw data alone is insufficient for the decision making. If you have so much data, on that basis you can't take any decision. But your information is sufficient. If your information is a particular, then it is very easy to take any decision. That means we can say the information is sufficient for decision making. Now for example, data is students' test score. But average score of a class is the information derived from the given data. Student test score is your data. But if you are finding out the average score of the class, so that will be the information. Now next one is data science. What is meant by data science? So data science is the field of study that combines domain expertise, programming skill, knowledge of mathematics and the statistics to extract meaningful insights from the data. So we can say that data science is a field where we can combine so many domain expertise, some programming skills, then knowledge related to mathematics and the statistics. On that basis, we can collect some meaningful data. And it is multidisciplinary approach that combines the principle and practices from the field of mathematics, statistics, artificial intelligence, and computer engineering to analyze large amount of data. So data science is one of the multidisciplinary approach. On that basis, if you have large amount of data, so you can analyze the data by using so many things like mathematics, statistics, artificial intelligence, computer engineering. It will be very easy to analyze large amount of data. So in this diagram also we can show that data science is totally related to math science, statistics, domains or business knowledge, then computer science and IT, machine learning, software development, and traditional research. So everything are included in your data science. Now organized data. This refers to data that is sorted into a row or column structure, where every row represents a single observation and columns represent the characteristics of the observation. So organized data. That means if you have collected the data, you have accessed data from many resources, and now after collecting the data, you have to find out the meaningful data. That means you have to keep your data in the structured format, in the organized format. We can say organized data means structured data. Structured data or processed data. So in this, you have to keep your data in row and column format. So in the row, in organized data, row is representing just your single observation, and the column is representing the characteristic of the observation. Now next one is that unorganized data. This is the type of data that is in the free form, usually text or raw audio signals that must be passed further to become organized. So here, unorganized data means whenever you will access a data, you want to collect the data. So at that time, you will collect data from various resources, and from various resources they will provide the data, and you will keep in one of the folder or in one of the uh, machine. So what you will do? Just you will access data and you will paste that data. So in this format, you are keeping just data, and that data is unorganized format. And that unorganized format means we can say the unstructured data, unprocessed data. And now, after collecting this type of data, that we have to process on it, and for processing you have to use various different algorithm. Like for example, we can say machine learning algorithm. There are so many machine learning algorithms, so you can use any algorithm for organizing the data. Now next one is data modeling. Data modeling is the process of creating a visual representation of either a whole information system or parts of it to communicate connections between the data points and the structure. So data model is just process for creating some visual representation. And definitely if we are talking about the visual representation, means that presentation or that image will show just information system, or we can say some information parts which are very useful for communicating between the connections of the data points and the structure. And the main goal of the data modeling is to illustrate the types of the data which are used and stored within the system. Actually, the relationships among these data types, the ways the data can be grouped and organized, and its formats and the attributes. So here, main goal of the data modeling is to illustrate the different types of the data, and that different types of data which we will use and store within the system, and they can recognize the relationship among the data types also. And the data model generally refers to an organized and a formal relationship between the elements of data, usually meant to simulate a real world phenomenon. So data modeling generally refers organized and the formal relationship between the elements of the data. Now what is meant by machine learning? So machine learning is a branch of artificial intelligence and computer science which focuses on the use of data and the algorithms to imitate the way that humans learn, gradually improving its accuracy. So in simple words, we can say the machine learning is a branch of the artificial intelligence and the computer science. And that you know that the artificial intelligence and the computer science both are focusing on the use of the data and some algorithms which are very useful for improving the accuracy of the humans. So machine learning allows the user to feed a computer algorithm an immense amount of data and have a computer analyze and make data-driven recommendations and the decisions based on only the input data. So, machine learning generally allows to feed a computer algorithm. So, on that basis, you have to use some algorithms and you have to analyze the data, and you have to make the data-driven recommendations and the decisions which will be totally based on your input data. Now next one is probabilistic model. Now, probabilistic modeling is a statistical technique used to take into account the impact of random events or actions in predicting the potential occurrence of the future outcomes. So, probabilistic modeling is related to your probability, and that is the statistical technique. And that statistical technique is used for taking into account the impact of the random events or what random actions, which are very useful in predicting the potential occurrence of the future outcomes. Now, for example, if you live in a cold climate, you know that traffic tends to be more difficult when snow falls and covers the road. We could go a step further and hypothesize that there will be a strong correlation between snowy weather and increased traffic incidents. So, probabilistic modeling will show just the chances, or we can say tossing a coin. Tossing coins means there will be only two chance. There are only two choice. Either you will get the head or either you will get the tail. So that means you will get the 50-50% chances of getting head and tail. So definitely, probabilistic model also will show the only the chances. How much percent is how many chances are there to getting that particular outcomes. So just in probabilistic model, you are predicting the future outcomes. So on that basis, you have to you have to use your inputs and you will get the outputs. Now next one is statistical model. A statistical model is the use of statistics to build a representation of the data and then conduct analysis to infer any relationships between variables or discover insights. So statistical model is use of the statistic for building a representation of the data, and then you have to conduct analysis for inferring any relationship between the variables and, or we can say, discovering insights. Now machine learning is use of the mathematical and statistical models to obtain a general understanding of data to make the prediction. So machine learning also will use some mathematical and statistical models for predicting the data, for predicting the outcomes. Then next one is that median. At the ordinal level, the median is usually appropriate way of defining the center of the data. Median is your center of the data, and the mean would be impossible because division is not allowed at this level. So we can also use the mode like we could at the nominal level. Next one is exploratory data analysis. Exploratory data analysis is an approach to analyze the data using visual techniques. Exploratory data analysis, that is EDA. EDA is generally just an approach which will be used for analyzing some visual techniques. And it is used to discover the trends, patterns, or to check assumptions with the help of the statistical summary and the graphical representation. And this exploratory data analysis is used for discovering the trends, some patterns, for predictions, or we can say for checking the assumptions which are available in the statistical summary and the graphical representation. Then next one is that quantitative data. What is meant by quantitative data? Quantitative data are measures of values or counts and are expressed as a number. Quantitative data are the data about numeric values, numeric variable. For example, how many, how much, how often. And the quantitative data could include its length, weight, number of toes on each paw. So here, quantitative data means just it will show the values or counts which will be represent the numbers, or it will be related to numerical numbers, numerical variables. For example, if you have asked how many brothers you have, that means you will say any number. So your answer will be in the number. That is a quantitative data. You will show some quantity like length, weight, how a number of toes. So everything you have to show in the number. You have to show the quantity of that particular data. So that's why it is quantitative data. Now, what is meant by qualitative data? The qualitative data describes the qualities or the characteristics. It is collected using the questionnaires, interviews, or observation, and frequently appears in the narrative form. For example, it could be notes taken during a focus group on the quality of the food at Cafe Mac, or responses from an open-ended questionnaire. So qualitative data generally describe the quality or characteristics of the data. And how we will collect this data? On the basis of the questionnaires, then interviews and observation. So you can collect the data, or you can ask some open-ended questions also. So on that basis also you can collect the data. Now for example, if you want to do survey, so that means what you will do? You will ask some question and you will get some answer and you will note down. So that is the qualitative data. Then next one is measures of variation. The measures of variation in statistics are ways to describe the distribution or dispersion of your data. That is just a description of the distribution and dispersion of your data. In other words, we can say it shows how far apart data points are from each other. And statisticians use the measures of variation to summarize their data. If you want to summarize your data, so at that time we can use the measures of the variation. And the measures of variation will shows how far apart data points are from each other. And we can say it will describe just a distribution or dispersion of your data. Now what is meant by data mining? The data mining is used to explore the increasingly larger databases and to improve the market segmentation. Data mining generally is used for exploring some databases and for improving the market segmentations. Now by analyzing the relationships between the parameters such as customer age, gender, taste, it is possible to guess their behavior in order to direct personalized loyalty campaigns. So here you are collecting a data in proper manner. In data mining also, you have to explore your large amount of the data and you have to improve your market segmentation. Now next one is that ratio level in data science. At the ratio level, values can be categorized, ordered, have equal intervals and take on a true zero. So in ratio level, just your values will be in the categorized format, in ordered format, or that can be take true value that will be zero also. So while nominal and ordinal variables are categorical variables, interval and ratio variables are quantitative variables. So your nominal and ordinal variables will be are categorical variable, and interval and the ratio variables are the quantitative variables. Interval and ratio variable will show the some numerical value, and nominal and the ordinal variable will show just categorization of the data. Now what is meant by the standard deviation? The standard deviation is a number that describes how spread out the observation. And standard deviation we will show by using the symbol sigma. So standard deviation, it's number, and that number will describe how spread out your observations. And the mathematical function will have difficulties in predicting precise value if the observations are spread. And the standard deviation is a measure of uncertainty. That means your standard deviation value can be changed. And in the standard deviation, your mathematical function can face some difficulties for predicting the values. So, next one is that discrete data. When values in a data set are countable and can only take certain values, it is called a discrete data. When your values are countable, at that time that data is the discrete data. For example, number of students in the class, number of players required in a team, these are countable. So that is where discrete data. We can easily count the variable in the discrete data. Now continuous data. Continuous data is a data that falls in a constant sequence. Continuous data is data that can take any value like height, weight, temperature, length are all example of the continuous data. In discrete data, it will show the particular number. Particular number means that number will not change after some time. For now, like we can say number of students in the class. There are 60. That number will change in only rare cases. This 60 means these are the number of students. Number of players for we can say the cricket. Number of players 11. For basketball that is 5. So that means just the number of players required. So this is discrete data. It is very easy to count. But in continuous data, your data will falls in constant sequence. And continuous data that can take any values like a height, weight, temperature, length. These all are the examples of the continuous data. And some continuous data will change over time. The weight of the baby in its first year or the temperature in the room throughout the day. Weight of the baby will change. Temperature of the room will change throughout the day. So, examples of the continuous data, the amount of time required to complete the project. Height of the children. Amount of time it takes to sell shoes. Amount of the rain in inches that falls in storm. So all these are the best examples of the continuous data. Now, nominal level data. The nominal data is data that can be labeled or classified into mutually exclusive categories within the variable. These categories cannot be ordered in a meaningful way. And for example, nominal variable of preferred mode of the transportation, you may have the categories of car, bus, train, tram or bicycle. These are the just nominal level data. These categories cannot be ordered in a meaningful way. Just these data are the nominal level. Now, nominal variable in the research. The nominal variable is a type of variable that is used to name, label or categorize particular attributes that are being measured. And it takes qualitative values representing different categories, and there is no intrinsic ordering of these categories. So in nominal variable, just you can take some name, label and some attributes. And these generally nominal variable will take qualitative values, and that qualitative values will represent some categories. and actually there is no any intrinsic ordering of the category also. The next one is ordinal data. An ordinal scale is one where the order matters but not the difference between the values. For example of ordinal variable include socio-economic status, low income, middle income, high income, education level, high school, BS, MS, PhD, income level less than 50k, 50k to 100k and over 100k. So here in ordinal data, just only order will matter. There is no meaning for the difference of the values. Now just we have seen like low income. We don't know what is the value of the low income. Just we have said low income, middle income, high income. So there is no meaning for the values. Just there is a meaning for the order. So that is the ordinal data. Now interval. The interval scale is one where there is order and the difference between two values is meaningful. For example, interval variable include temperature, Fahrenheit, temperature, Celsius, pH, SAT score, credit score. So here in interval scale, that means we can say interval means just we can say the range. It will show the range and it will show the order. There is a order, but definitely if there is difference between the two values, then there is a meaning for that difference. So this is the interval, that difference will show the range. Now for example, 100 to 150, this is the range. 250 to 350, this is the range. So definitely if you will get any difference like 50, 100, so these values are very important. We can't ignore this. So this is about the interval. Now next one is the ratio. A ratio variable has all the properties of an interval variable and also has a clear definition of 0.0. When variable equals 0 to 0.0, there is none of the variable. So ratio variable is almost equal to the interval variable. For example, ratio variables include your enzyme activity, dose amount, reaction rate, flow rate, concentration, pulse, weight, length, temperature in Kelvin. 0.0 Kelvin means there is no heat and the survival time. So this is the ratio variable. Now in this diagram you can see there were different levels of the data, and these are the levels of data. There are four different levels of data: nominal data, ordinal data, interval data and the ratio data. Here ordinal data and the nominal data are involved in the qualitative data, and the ratio data and the interval data are quantitative data. So nominal data just it will show the categories. That means there is no any order or no any direction. Then ordinal data, it will show the ordered categories. Like it will show the rankings, order, scaling. Then interval data, just difference between the measurements but no true zero. It will show the difference between the measurement, but it will not contain the zero. Then ratio data, difference between the measurements, true zero exists. And in ratio, it will show that some difference between the measurement, but there will be available zero value also, true zero value. So this is all about the levels of the data. So this is all about definition and terminology of the flavors of data. These are the references, so you can go through these references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.